Hello everyone, so in this video, let us talk about the first three problems from the Leetcode weekly contest 316. So let's start. The first problem is determine if the two events have conflicts. So you're given two arrays of string as you can see in the input, event 1 and event 2, and these two events occurs on the same day. Now, these two events are having their start time and end time. So as you can see, now it is in this 24-hour format, so like hours and minute. So it is a 5-letter string. Okay, now you are given these an event, start time, end time, start time, end time, and it is on the same day. Okay, now you just have to tell that whether these two events have any conflict. By conflict means that they intersect or not. If they intersect, return true. If they don't intersect, they return false. That's the overall thing. Now it's pretty simple. You have an you first have a hour minute type of format. First convert everything to minutes. Okay, but it's very simple. Then if you have everything in minutes, let's say it starts at, let's say, 200 minutes from the zeroth. Okay, zero means that the very beginning of the day. It starts at any, let's say, 200. It's end at 220. The other starts at, let's say, 400 and at 440. So you directly understand that these are not intersecting. Okay, so these are the, you can say, the intervals. Now how can you check that two intervals are not intersecting? Okay, now to check that whether two intervals are not intersecting or not intersecting or intersecting, just do the reverse of that. If you want to check it for intersecting, why not just check out for non-intersecting and all the other cases are intersecting, because the cases for intersecting are very large. Like it can be like multiple. You have to check for multiple cases. What I mean by this is, let's say this is one interval. Okay, then the other interval can be like this. Okay, this interval is just touching out, or maybe it is just out of it, just touching, or maybe it's completely inside the, or maybe like this. Okay, so this is one interval, and similarly vice versa for the other interval as well. So there are multiple cases for checking out whether two intervals are intersecting, but what you can actually do is that check that whether they're not intersecting, and that's very simple. If one interval is like this, and the, let's say, the value of this is a1 a2, and the other interval is b1 b2, it's very simple. You can just check out that either the other interval will be here if they're not intersecting, or the other interval will be here if they're not intersecting. Okay, either it will be completely on the right hand side or completely on the left hand side. If it is completely on the right hand side, then obviously this is, let's say, b1 b2, so b1 will be greater than a2, complete, like strictly greater than a2. And if it is on the left hand side, then if it is like this b1 b2, b2 should be strictly less than a1. If either of these conditions are true, then it is completely on the right hand side or left hand side. And the reverse of that, like the, you can say, like the, you can just find out the opposite side of that. So if it holds this condition, then it is out of bound. If it is not holding this condition, it is inbound. Okay, it is somewhat intersecting. That's all the logic for the first problem. So what we have done is that we have first written this convert function that will convert every event, start time, end time, to you can say the minute representation. So minute of a1 and a2. So just like a1 a2 minutes, and minutes of b1 b2. Okay, convert all these events here. And what we've done is that if it is on the right hand side, then obviously b1 is greater than a2, and if it is on the left hand side, obviously b2 is less than a1. Okay, these are minutes. If all of them, if any one of them is true, then it is out of bound, but I have to find out whether they're intersecting. So just do a negation of that. Okay, and then you just, this is the convert function that will just take out the string. Okay, this is the minute. Okay, just take out, let's say, 24 minutes. So 24 to 2. Okay, take out 2, multiply with 10, and 4, 24. And if it, let's say, 60, like 16 hours, so 16, which is like the same here, but hours we have to convert to minutes, so multiply with 60. Okay, that is what we have added an answer, return the answer. That's just converting the whole string, okay, this string s, into its minute representation. This is the first problem. Moving on to the second problem. The second problem is number of subarrays with GCD equal to k. So GCD is just common, like greatest common divisor. Okay, so it's pretty simple. What you can see is that you are given an array, and you have to find a number of subarrays, continuous arrays, you can say slices of arrays from this bigger array, that is called subarray, such that the greatest common divisors of those subarrays is equal to k. Now you can see the constraints are pretty small, like it's 1000 only. So you can do an O of n square type of approach here, because it will be like inbound. Okay, and thus you can just find every possible subarray, because okay, and then just check out for every possible subarray that whether the GCD, what's the GCD of that. If the GCD equal to k, then print out the answer. Like keep on incrementing the number of subarrays we have counted out, print out the answer, because it's very simple, because the constraints are pretty small. So I'll just tell you very brief. What you can do is that, let's say you have the subarray, which is like this is only 9312. So 9312, and then 63. So 63. Then starting from every start point. So let's say subarray, which is only consist of this, that is 9. Then starting from this only, okay, 93, 931, 9312, 93126, 931263. This is all the subarrays starting from the first position. Then all the subarrays starting from the second position. So 3, then 3 1, then 3 1 2, 3 1 6, 3 1 6 3. All of those subarrays. So you will keep on like checking that what is the GCD of this. Then if you calculate the GCD of this, you can take the same GCD and do like append this number to that GCD, and it will like combine GCD of these two numbers. Then you have calculated the GCD of these two numbers, then append this number also in the GCD. You have now the GCD of the combined numbers, because GCD is that additive property. So you can like take the number, next number, and it will keep on appending in the GCD. Then you have the GCD of all these numbers, like take this number also in the GCD of this. Now you have the GCD of all these three numbers. So anywhere we find out that the GCD of any set of like, subarray is having equal to k, then you just increment the answer. Okay, that's the logic for here. Now we update this is total to total count on how many subarrays we have in the answer. Then iterate over every from I equal to 0 till all the n. So what we have done is that for the current number we have started with nums of I, and j equal to again start from I till n. So this is the starting point of the subarray, this is the end point, which is j. Then what we have done is that the current GCD at any jth point starting with any I is equal to we just append this particular number inside the GCD. Okay, calculate the GCD. That's the function that you can use. In different languages you can implement the GCD function as well. It's very simple to implement. And in C++ that you can directly use this function to calculate out GCD. Now you have the GCD of the subarray. Now what you have done is that if at any point if the answer become equal to k, which means that you have got the subarray GCD equal to k, you just increment the answer and just print out the total answer. That how many total subarrays have the GCD equal to k. Pretty simple. So that's the second problem as well. Moving down to the third problem. The third problem is minimum cost to make array equal. So what you are given is that you are given a 0 indexed array nums as well as cost. So you're given two arrays, each of n positive integers. Okay, as you can see in the input as well. Now you can do the following operation any number of times. The operation is that you can increase or decrease the element inside the array by 1. Okay, so you can just take out any number, increase its value or decrease its value by 1. But for doing that operation, you will incur a cost, and the cost is equal to cost of I. Now for that you have different cost associated for every number to increase or decrease. Okay, and you just have to return the total minimum cost such that all the elements of the array becomes equal. Okay, you have to just make all the numbers array equal. There's no foundation on what number should become equal, but the only thing is that they should become equal. And given cost is that if you do any operation, then the cost of any operation is this for that particular number. That's the overall problem. Now what you can what I directly think over this problem is that, okay, let's think that I take a very high number to make all of them equal. Okay, these are, let's say 1 3 5 2. Okay, if I want to make them very high, let's say equal to, let's say 1000. So all of the numbers have to increment these values and make them 1000. Okay, so let's say the cost of that is equal to let's delete this out. So let's say I have some numbers, okay, and I want to make all of these numbers equal to 1000. Okay, so let's say the cost of that is, let's say C1. And if, or let's say now if I want to make them equal to 2000, okay, more than that. So what you can see that obviously if I want to make it more larger, then obviously what will happen? You directly understand that this will obviously be larger because C2 will be larger than C1 because I have to make it more higher. And similarly, if I make it more higher, the cost will increase. So if I go on the right hand side of the spectra, the cost will increase. Similarly, if I go on the very left hand side of the spectra, what I mean by this is, let's say I have the cost of, let's say all the numbers are, let's say 100, not 100, let's say greater than 100. So 100, 105, okay, 100, 200, all of those, something like that, greater than 100. Now if I somewhat make them, let's say equal to 10, okay, so I have to somewhat decrease all of these numbers to 10. Okay, so I have to do some cost. Let's say the cost is equal to C3. And if I want to make all these numbers equal to, let's say 2, then I have to decrease more. So obviously more decrement of these numbers, so the cost will be more. So which means that C4 will be greater than C3. So what you can see that either if I go on the very left of the spectra or very right of the spectra, the cost increase. And the cost is somewhat in between of that. And whenever I see such type of pattern, okay, so you have two patterns in which binary search can be directly used. One pattern is that if it is continuously monotonic, okay, so let's say like what you can see that until some point it is not giving any answer. After that it start giving any answer. Okay, so there is one point of inflection, you can say, okay, in which like this is the point you want. Okay, and the other case can be that either on the left hand side of the spectra the value increases, right of the side of the spectra the value increases, and there is a point, a sweet spot, okay, at which we want the correct answer. So if we go on the left, move on the right, like right hand side of the spectra, we keep on increasing our like the value I want to get to, the value increases. Okay, either also on the left hand side of the spectrum the value increases, but there's a sweet spot in the middle in which if I got there then the answer is correct. Okay, so I want to reach there. In those scenarios also you can use binary search. So how can I use binary search? So what you can see is that let's say this is the value, okay, I want to reach to. So I want to make all the numbers equal to some value. Let's say the value is equal to, let's say, x. Okay, so what you can see is that x can range from, let's say, 0 till a very large number. Let's equal to 10^6, very large number. So if I have any number, let's say I've taken this middle value, like can I reach there? So I just calculate out how many number of steps required to reach there. That's very simple. I can get in O of n. But if I somewhat go on the right hand side of that number, let's say x plus 1, and if the value increases, then why should I go on more on the right hand side? The value increases, so I should go on the left hand side. And if I am on this side of the plane, if I decrease the value by 1, the value will again increase. So I should increase the value by 1. So either you are here on this slope or this slope, you have to somewhat get to the bottom of this particular point, just get the answer. Okay, that's the overall. So for every x you have to compare it with the x plus 1 or x minus 1. Okay, and like if you are going down the slope, then it is fine, else you have to just print out the answer when you go to the very bottom. That's the logic that we have to use here. So how we can calculate out the number of steps? So you have any number, let's say these numbers, and I want to make it, let's say, equal to mid. I know the value I want to reach to. So what I can do is that I can iterate over all the numbers and I want to reach there. So let's say this is 100. I want to reach, let's say, equal to 110. So I have to increase by 10. And for every increment, I know how many steps I've required, like, or how many per cost it will take. So I can actually just subtract out these two values and multiply with cost. Even let's say I want to, let's say, equal to 90. So this is the you want to go down again. So you just have to find out the absolute difference between the value I want to reach to and the current value I'm on, and just multiply it with cost for per step cost. You will get how many costs it will take to reach this particular value for every point. You have to do it for every point. So it's an O of n approach to iterate over the whole array and got the answer. So like how much step it will take, and you will keep on doing this until you reach the sweet spot of like what's the minimum cost it will take. That's the logic for this problem. Let us go down to the code so that it will become more clear to you. So we have n, okay, the total number of elements. This is left and right, and we will do this, keep on doing this operation. We'll go to the mid. We will call this check function. Let us go to the check function first. So let's say what this check function will return. Okay, so let's say I got this middle and I somewhat reach here. Okay, so I will every time take the current mid I am on and compare it with mid minus 1. Okay, so mid minus 1. So mid minus 1, if what you can see, if mid minus 1 is, so if mid minus 1 is, you can say, is larger. Okay, if mid minus 1, which is this is mid minus 1, if mid minus 1 is larger, then I have to go on the right hand side. But if I am on this mid, okay, and mid minus 1, that is this point, mid minus 1, if mid minus 1 is smaller, then I have to go on the left hand side. Okay, then I have to like somewhat, what is my range of LNR? I have to go on the left hand side. If mid minus 1 is larger, I have to go on the right hand side. That's pretty much simple. So if mid minus 1 is less than, okay, I have to somewhat go and on the right. So what you can say that I would go on the left hand side. Okay, so like R equal to mid, and if this value, like if I just send this mid, and if mid minus 1 is smaller, okay, smaller than mid, then I have to go okay, if it is larger, then I have to go to the right hand side. If it is smaller, then I have to go on the left hand side. Pretty much simple. You can read down the code. It's pretty much simple. So I have to check out with mid minus 1 and how you can calculate out this. So this is a calculate function that will just calculate out for two values. Okay, mid and mid minus 1. So the function is same. That's why I've written the same code, but it will calculate out for both of these values. So the answer is 0. How many cost it will take? Iterate over all the numbers. Just add out the minimum, like the absolute difference between the value I want to reach to, that is mid, and the value I'm on. into the cost it will take for each step, and just add it out and just print out the answer, return the answer. So according to the value I am on, I have to move this sweet spot, and the end. The answer is obviously either it is like the mid or mid minus one. So it is answer is L, which I've reached to, or L minus one. So just minimize both of these values because I have to return the minimum cost, not the minimum value I have reached. Like I want to reach to. This is the value that I should reach to get the minimum value, but I have to return the cost. So cost is, again, you can calculate out using this function. You just calculate out the cost for both L and L minus one, and what is the minimum of that, just print out the answer. Pretty much simple as it is. So it's a binary search problem. It's a very good binary search problem in which you have to understand, like, binary search can be used on two types of thing, okay, in a monetary function or in a decreasing, like a slope, you can say valley type of problems, or like mountain type of problems also you can do. So there's a problem, a very good problem on which you have to find out the peak of a sorted array, okay, like your sorted array, it is rotated sorted array, so it's a peak, okay, the pivot, that is also like that. This is a valley type of problem, that's a peak type of problem, okay. So those are very beautiful problems on binary search, and that's the solution for the third problem as well. If you still have any doubts, you can mention in the comment box of this particular video. I will see you in the next one. Till then, coding and bye.